Hello, everyone. We are still seeing few people who are joining in, so we'll just wait for a few minutes before we start the webinar. Thanks for your patience. Okay, so we're good to start. Welcome, everyone. Thanks for joining in such large number. I can still see people joining in. Thanks for your response. So my name is Avinash Tiwari, and I am co-founder of Smart Software Testing. Our product Pcloudy is Pcloudy is app testing platform which enables app teams to create high quality apps. So some basic housekeeping rules before we begin. This talk is going to be around 35 minutes, and I'll be taking questions at the end of session. But you can post your questions during the session itself in the questions tab. Towards the end of session, we'll try to answer most of the questions that you have raised. If you're not able to answer that, I promise that I'll be sending a one-on-one email for your questions. So thanks for taking your time out today, and I hope you'll be able to take back something and implement it within your organization. So as the topic says, we're going to talk about mobile app testing strategies for 2020. Mobile app is an evolving area, and these strategies are changing very, very fast, depending on the need of the business. So that's what we're going to see today as to how these strategies have evolved over a period of time and what can we expect in 2020. But before we begin, a quick snapshot of our journey as a company and as a product. So we're very proud to say that we are near about 100K users from across the globe, spanning across 700 customers, out of which 30 plus are Fortune 500 brands. We have been recognized by top analysts like Gartner, Forrester, and have appeared in multiple reports as one of the key player in the mobile app testing space. Some of the enterprise names whom we are working with, you can see on the screen. In terms of our product, as I mentioned in the beginning, our objective is to enable teams to take a leap as far as their digital transformation initiatives are concerned. So in that context, we have two components within the product. The first is Mobile Device Lab, which enables teams to create an infrastructure for their mobile app testing needs. And on top of it, it comes with variety of tools which helps the manual app testing teams as well as the automation teams to have their functional as well as automation tests run in a very seamless way. The second component is a zero code automation studio, which allows rapid automation creation for your mobile applications. So while you are testing your application for functional test cases in parallel, it can generate the scripts in a codeless way, which then can be used to run on devices in parallel. So combine these two, Mobile Device Lab and Zero Code Automation Studio, enables quality at speed for organization as far as mobile app testing is concerned. Now coming to the topic and what we're going to cover. So mobile app is a growing area, evolving area, and it's very important to understand some of the trends which are currently happening in the market. So that's going to be the first focus for me. Then, before I move to the actual topic, I just wanted to talk about a few myths that exist as far as the app testing is concerned. And then later part of the this later part of the presentation I'll be mostly talking about what are the journeys that the app teams have taken to build their strategies, and what should we expect in 2020. So let's start with some of the key trends. So what you see here has been taken from a report which was published just a few days back, and there is something to ponder about. It says that most of the growing base of internet users are mobile only with no PC access. As you can see, the arrow mark in 2025, the growth is seen in the mobile only generation. They're not going to have any access to PCs at all, which is huge. And it means tremendous expansion of app and digital content for that next mobile billion, for that next billion mobile only generation, and which means huge scope of growth as far as app development and app testing is concerned. Now, at the same time, we all are aware that device fragmentation and OS fragmentation issues are making life of app developers and app testers very, very complicated. And as you can see in the first chart, the number of smartphone models have doubled in last 4 to 5 years. So in each region, you can see the number has doubled. So if you look at North America, the number of smartphone model has doubled from 4,760 to 9,395, and same trend is seen across. So that's about device fragmentation. If you look at the OS fragmentation, life is not better there as well. If you look at the world of Android, we are still talking about the last 5 to 6 versions which are popular in the market. On the right side table, you can see if you have to have a decent coverage of around 50%, you'll have to plan testing of at least last 5 versions, starting from 5.1 to latest 9, and the data for 10 is still not available, has not been released by Google yet. For iOS, it's quite better. You need to focus on last 2 versions, but we are still not talking about the different resolutions and different models of the devices available in the market. So these two combined, device fragmentation and OS fragmentation, requires testing to play a key role in making sure that the apps are compatible when they're released in the market. So once we have seen the issues with the fragmentation, what I want to highlight here is some of the reasons why apps fail. And this is a data that we have collated based on the issues that we see on our platform for Android applications. And as you can see here, there are 2 different categories. The first category is device specific, and second category is non-device specific. Within device specific, there are different reasons why apps fail, and most of these reasons, like problematic driver implementation, OS customization, or peculiar hardware composition, are very OEM specific phenomena. So you might be aware that OEMs pick up the operating system which is released by Google, which is called Vanilla, and then they customize it to suit their needs. At the same time, they also customize the hardwares. They customize the drivers. So for example, every phone is striving to be the best camera phone, and they change the drivers, audio drivers. So all these implementations are very, very specific to OEMs. OS customization is a big phenomena. The skins are changed. For example, Samsung has a multi-window mode, while Google Pixel doesn't have. So if your app has to work on Samsung and Pixel together, you need to make sure that your app works in multi-window mode. Similarly, peculiar hardware composition. So these are some of the reasons because of which device-specific issues happen. And if you look at the percentage of such issues, these are close to 40% of issues that we have seen on our platform are because of device-specific challenges or device-specific fragmentations. If you look at the non-device specific category, that's consists of almost 60% of the bugs that we have seen. And within that, very clearly, Android platform API evolution is one of the big um, problem area. So, like every version that we saw in the previous slide is linked to an API version. So API 26 was released. There was an internationalization issues. So similarly, every version that comes in the market, you require to make sure that your apps are compatible with those API versions. And there are a lot of issues that occur within the applications. So again, that leads to the fragmentation as far as the operating system versions are concerned. So if you look at the overall data, it clearly shows that the number of issues that happens because of fragmentation issues are quite significant, and we can't look away from these fragmentation issues. So having said that, having established the fact that fragmentation is a key issue, uh, I often get this question, why real devices? Um, whatever testing that needs to be done, we can do it on emulator simulators. And that's where I think there's a myth that exists that emulator simulators are enough for testing. So while you can see on the screen, there are some benefits with respect to emulators and simulators. For example, simulators are very easy to set up, it's freely available, it's definitely faster, it's less flaky as far as the automation executions are concerned. But the bottom line is that the 40% device OEM specific bugs that we saw in the previous slide cannot be caught on an emulator simulator, because these are typically the vanilla versions given by the OEMs. The customizations that they do are not available on emulator simulators. And apart from the fact that there are no real networks, you can't, there are issues which are related to the resource consumption and all cannot be found out in the when you test on emulator simulators. So basically these can be used to do some basic functional tests, some UI issues. It's quite helpful in the development stage where the developers are quickly deploying the app and seeing how it works. But when it comes to real testing, what we have seen is real devices are the answer, because they are, I mean, these are the real production environment. So why do you want to test anywhere else if you have something so close to your production environment? That's one thing we struggle in some of the other platforms like web or other enterprise applications. But in case of mobile applications, you have something exactly close to your production environment. So why do you want to test somewhere else? The challenges are related to cost, of course. How many devices can you buy? How many devices can you keep? How do you make sure that you keep getting newer devices that comes in the market? And of course, there are some flackiness which happens during automation runs. But that's where I think platforms like Pcloudy comes into play, where some of these challenges can be addressed. So bottom line is real devices are the game for mobile application testing. And we are not just saying this this exists in the market. Some of the trendsetters use the same approach. So look at the Facebook story. They have a device lab of more than 2,000 real devices, and they use this lab to rapidly test their applications and release almost multiple times in a day. And this helps them practice continuous testing. So they're not doing testing twice, once on emulator and once on real devices. All the testing that happens happens on real devices, and that's the reason why they have invested in these labs. And that's the reason why they're able to serve billion customers across the globe. So you can see the trend and kind of take cue from this. Okay, so having talked about the trends and some of the myths, now we are here, and that's the main reason why we are doing this session today. So what I'll be doing now is, before we talk about the 2020 strategy, I'll be talking a bit about what's the journey of app testing strategy. What are the typical scenarios that we see when we talk to the organizations? And within that context, I have uh, broken this whole journey into two different milestones, and I'll be talking about each of the milestones one by one, and then we'll try to talk about the 2020 as a third milestone. So to begin with, this is one of the typical scenario that we see when we talk to most of the organization. And though we are in 2020, unfortunately, this is one of the, this is quite prevalent scenario that we see in the app teams where they have certain physical labs, which means they have procured certain devices, 5, 10, 15, and those devices are lying in their lab. These devices are assigned to different users based on register, physical register or web register. If someone locks the device and goes home, there's no way to get that device. Other teams are waiting for those devices to be available. So that's how the device infrastructure works. During the release for all the new feature testing, it typically happens manually by accessing these physical devices and testing those test cases for the new features. The regression, so the teams have created certain UI-based automation regression suites. But the challenge here that we see is they're mostly running it sequential on few devices because they have to connect those devices through USB to their systems and start running it. They haven't yet figured out the parallelism in that case. And with this approach, they are able to release only once in a few weeks. So that's one of the commonly, as I said, commonly prevalent scenario that we see within enterprises, within app teams, and I'm calling that as a stage one, the beginning. So if I try to kind of convert that in a much more structured way, like consultant, when they do the audit and then try to link it with the parameters. So device infrastructure here in this stage one is local physical lab. The app handovers from developers to QA happen either through mails or some internal repository links. New feature testing happens manually. Regression testing is typically UI-driven automation through tools like Appium, and the coverage is pretty low, which is somewhere around 30-40%. Automation trigger is manual, so as soon as the release comes, the QA engineer or the developer will trigger the automation and run it and then look at the results. The scale of automation is very minimal, as I said, sequential on few selected devices. There's no testing on production, which or any shift right testing to be more precise. Test analytics is very basic manual reporting where you once the testing is complete, you fill that data in Excel sheets or and then generate reports. So that's typically the beginning stage of the app testing strategies that we have seen, and still large number of organizations are at this stage. However, there are organizations who have matured, and we are calling it the midway stage. So here, change from the what we saw as the beginning stage is as they start maturing, what they realize is that their local physical device lab is not enough, so they need access of on-demand cloud lab as well. That's where they look at solution like Pcloudy. So they use these solutions in conjunction with their physical labs. So it's now a combination of their physical devices with the on-demand cloud. The new feature testing still happens manual, but now they have invested in certain infrastructure to build parallel runs. So you can see you have to buy Mac Minis or certain other servers, USB hubs to connect your devices to these infrastructures, and then convert your framework to be able to run the automation scripts in parallel. And this is a huge effort, both from cost as well as effort perspective. One big change in this stage is organizations realize that the UI automation is not enough. So they start looking at automation pyramid in some way. So one starting point is API automation. So UI-based functional automation with API automation becomes the two key areas where the automation happens. And in these situations, what we have seen is the UI-based functional automation coverage is beyond 50%, somewhere close to 60 to 70%. Another change is the automation trigger is through some CI tool like Jenkins or other CI systems, and the teams are able to run it nightly or based on certain schedule that they have for the releases. And this helps them increase the release frequency from what we saw in the stage one, which was once in few weeks. This brings it down to maybe multiple times in a week. And because now they have the automation runs which can be triggered through CI, there could be scheduled runs on the production as well. So this helps them do some kind of synthetic monitoring on the production as well. So that's typically we see a mid stage of maturity for organizations. And if I again go back to my parameter-based listing, you can see the change. Device infrastructure is now a local physical lab for plus use of external cloud on demand. App handover is now through CI systems or app distribution platforms like TestFlight. A new feature testing is still manual. Regression testing is now much improved. From the UI-based functional automation is close to 70%, along with additional API automation. The automation trigger is CI system. Test analytics is still manual. The scale of automation is much better than what we saw. So now, instead of sequential runs, there are parallel runs happening on few selected devices. And testing on production is also possible because there is a CI in place and it can be scheduled. So that's what we call it a midway stage, which is much better than what we saw in the beginning stage. And this is where we see a lot of organizations again kind of struggling to move to the next stage. And now that's where the Vision 2020 comes into play as to what should be the next stage of evolution as far as the app testing strategy is concerned. Now, before kind of we talk about the vision and what are the different strategies, we need to be very clear about the goals that we're looking at here, right? So one of the key goals to look at the next level of strategy is to increase the speed of the release, right? So we talked about number of releases, which could be multiple times in a week. Here we're talking about multiple releases in a day without impacting the quality. And for that, how can the testing team be ready to make sure that they are not creating any bottlenecks as far as the this increase in the speed of app release is concerned? So how do we ensure that those bottlenecks are not there is what the 2020 strategy is, and that's what I'm going to talk about now as we go along. So as part of the 2020 strategy, if we are looking at the multiple, we are looking to achieve a state where we can do multiple releases in a day. There's no other way than going to the continuous testing strategy, right? And if you look at this diagram, which explains this process very, very well, where testing is happening continuously at every stage. So be it your plan, your code, your build, release, deploy, monitor, at every stage there is a testing happening. And if you look at it, it's very easy to understand how much testing is happening in the shift left and how much testing is happening in the shift right. So we talked about testing on production, which is typically the shift right testing. And here, in this case, we are talking about testing during the code, as well as merging and during the build stage, which is shiftless testing. We're not waiting for the release to happen to test on maybe pre-prod or staging environments. So that's what is so continuous testing typically is the combination of the shift left and shift right testing, which helps you do testing from beginning to end. So that's one of the key goal which we should be looking at to move to the next level in 2020. And that cannot happen until we focus on maximizing the automation. So if you look at the number of times that you need to do testing in the continuous testing phase, it's absolutely not possible if you're relying on the manual approach. So maximizing the automation is the only way to move forward. And to maximize, one way is to look at how do we implement automation pyramid. Uh, in case of mobile app projects, still a debate. What is the right automation pyramid? Is it a standard one or is it a flipped one? But I'll keep it simple. The point is you have to look at automation at every stage. So in the midway stage, we saw end-to-end UI functional tests somewhere around 70%. That has to increase to 90-95%. It has to be supported by unit test using tools like Espresso or XCUI test, which can be used in stages like coding or branch merging, etc. And then API tests wherever applicable. So by combining these three things, we can run the relevant tests at different stages, and that will help us achieve the continuous testing stage. Right? But only can the maximization of automation only way to achieve the continuous testing. I mean, in my observation or in my experience, that's not enough. That has to be supported by quite a number of other things. And there are three things which we have mentioned here. The first is you need to have the right infrastructure. If you're talking about automation at this scale where it has to run almost continuously, there has to be a right kind of infrastructure in place. The second is what we call a test orchestration, which again is an important strategy when we are talking about continuous testing. And the third is test analytics. Now, I'll talk about each of these slightly in detail. Let's start with the infrastructure at scale first. So we talked about running tests in parallel in the midway stage, but that's a baby step. It's very easy to create a framework or a infrastructure where you can run it on 5-10 devices. But how do you achieve a stage where you don't need to worry about the number of devices that you want to run your automation scripts on? I want to run on 20, 50, 100 devices, and my framework and my infrastructure should be able to scale. That's where something like Pcloudy comes into play, where it allows you to create an infrastructure at scale. It could be an internal or an external cloud. Here, what you see here is an APM project running into on almost 50 devices together, which is an internal cloud created for a customer. So by creating this infrastructure at scale, you are not worried about the infrastructure part of it. What you are worried about is how can I maximize the coverage of my scripts? And as soon as my coverage of script is run, I have the infrastructure in place to run the scripts and achieve the scale that I want. And if I need to add more devices, I should be able to add it without any hassle. So that's where infrastructure at scale helps achieve continuous testing, where the teams are focused on creation rather than focused on building the infrastructure. The second part is the test automation orchestration. So we talked about increasing the coverage of the tests, right? And in some cases, the number of tests can be pretty huge. So how do you achieve the optimum execution time is one big challenge in a continuous testing environment, because you can't run all the tests all the time. And that's where orchestration comes into play. And one way to orchestrate is using something called CI pipeline. Most of the tools, CI systems provide this feature. What you see here is a screenshot from Jenkins. So as you see here, Jenkins allows you to create collection of jobs which can be scheduled in a certain order. And in this screenshot, you can see you have unit test schedule. After that, integration tests can run, then a test can run on staging environment. So you can create these schedules and then your tests can run. And within those schedule, you can have ways of selecting right test cases which can be run during these jobs. So by creating some CI pipeline, you can achieve certain level of orchestration to make sure that your tests are running without any manual intervention. And then your pipeline is moving from one phase to other without any interruption. But in case of mobile app, there is another level of challenge that we have seen, and that's where there is a different level of orchestration which is required, which can be also called a distributed running mechanism. So, for example, in this, let's say there's a automation suite which has 500 tests, which is of 500 tests, and you want to run on 50 devices. One way is to run all the 500 tests on all the 50 devices, but then that's very time consuming. Let's say if the 500 tests are running for on one device for 4 hours, 5 hours, then you have to wait for those 5 hours before your execution is complete. To avoid that kind of situation in a continuous testing environment, if you're running once in a while regression test, you can't avoid running all the tests on all the devices. But in a continuous testing environment where you're running the scripts on daily basis or maybe even more frequently, the orchestrations allows you to distribute the tests. So rather than running all the tests on all the devices, you have a middle layer in place, which is orchestrator, where it randomly picks the test cases to be executed on a specific device. So all the 100 tests are not running on all the devices. It has picked up, let's say, 50 tests for each device. And it can be changed, let's say maybe 10 test cases on each device. And it does in a randomized way so that over a period of time on one particular devices, all the tests are running. So you are still achieving a full coverage on a device, but distributed over a period of time. And at the same time, you are minimizing the execution time for a particular execution. So it achieves both the purpose. So in a continuous testing mode where you have a very large test suite, you need that intelligence to optimize the execution time. And one of the ways to orchestrate. There are a lot of other ways, risk-based selection of the test cases, etc. But if you just distribute it, it helps in minimizing and optimizing the execution time. So writing an orchestrator can be a big challenge, and that's where a platform like Pcloudy can help, where it allows orchestration on its own. We'll soon be releasing this feature for the public, but it's going to solve your effort of creating that kind of layer to be able to orchestrate. So that's the second piece of orchestration. So we talked about using CI pipeline and the distributed running. The third piece that we talked about for the success of continuous testing is test analytics. So now you're running automation at scale. You're talking about, let's say, 500 test cases, 1,000 test cases running on 50 devices. How do we even, and that too running so frequently, how do you even debug those failures that happens and take corrective actions? You can't wait for days to correct those issues because your next cycle is already scheduled. So you have to quickly figure out how do I correct the failures and what are the reasons of these failures. If there are bugs, I need to report to. If there are some script changes, that I should be able to do it quickly. That's where test analytics comes in play. And a platform like Pcloudy gives you capability to analyze those reports in a very, very seamless way. So you can see one of the execution here where it says the execution is completed. There are 15 pass, one completed, one error, one fail. And while the execution is going on, you can monitor this dashboard where you can see the different categorization. So how many test cases are still running, how many test cases are already passed, and then you can also see how many test cases are failed. And it is only showing right now the test case which has been failed and which are having errors. So you can just focus on that test case rather than looking at the whole report. Then if you drill down to which test case was passed or failed, you can see a very intelligent log and information available to you, which can help in quickly figure out what are the issues. So things like logs, JSON format results, screenshots of only that test case is available. The video files, the log files for only that test case is available for you to be able to quickly analyze and debug. And on top of it, I'm not showing the dashboard there. You can compare different runs at the same time and see how a test case is passing over a period of time, build over build. So that kind of analytics will help the development teams and the product teams analyze what's going wrong. If a particular test case is failing more often than not, then someone needs to do something about it. So it enables two things. One is a quick debugging, and second is giving you the kind of data for you to take right actions and maybe improve the development process itself. So now here we are at level 3, which is the 2020 strategy that I've been talking about. I'm calling it a continuous. So we talked about the beginning stage, midway, and this is the third one, which is the continuous testing approach. And that cannot happen unless we have the right parameters in place. So for example, device infrastructure has to be a cloud-based. It can't be a physical lab if you're looking at automation at scale. It could be internal, it could be an external, but it has to be cloud-based for all kind of testing. The app handover to developers to QA has to have CI pipeline. It can't be an individual CI trigger. New feature testing, in case of mobile, there is definitely manual testing which is involved because there are a lot of sensors. There are still a lot of automation which is not possible because of the nature of mobile devices itself. So there is a bit of manual effort definitely involved, but at the same time, in sprint automation to maximize the coverage is required so that your scripts are ready for the next sprint or the next release cycle. Regression testing has to be more than 90% to make sure that we are talking about continuous testing. Automation trigger is CI pipeline. Test analytics has to be automated, like the way we saw. We call it progressive reports. You can call something else, but it has to be automated. You can't rely on creating manual reports for analysis. The scale of automation has to be continuous, using pipeline and orchestration and with infrastructure at scale. And the testing on production can happen, production as well as any other environment that you have, that again can happen using the continuous runs, using the CI pipelines. So stage 3 is what we are looking at as the vision that you should have to take your testing and make sure that the app releases are happening in a much more quicker way, and that will really help the business and direct benefit to the consumers, because you're able to release much faster than your competitor. So to summarize, we talked about the level 1, which is beginning, which was typically manual testing using the physical devices or emulator simulators, supported by UI-driven functional automation. The coverage is pretty low, which is 30-40%. Then we moved to intermediate stage, where it was combination of local device and external cloud, automation in parallel to certain extent, and there is partial CI/CD implementation. But third stage is what is what the vision is, where we are looking at continuous as level 3, and that's what we should aim for, where automation is at scale using internal and external cloud, a full-fledged CI/CD pipeline, and adoption of automation pyramid for continuous testing. So with that, I'll kind of close this session. Hope I have given some food for thought, and some of the strategies probably you can go and read more. You can talk to us if you want to know more about any specific strategy. We'll be happy to implement that. I'm open to questions here. Thank you so much for listening patiently, and we are ready for question and answers. So there is a question, how can we deal with execution speed on iOS? So I'm not sure if you're talking specifically in context of any tool, but it primarily depends on the tools which you are using. So for example, if you're using Appium, whatever speed that you get with Appium on local devices, you can get it on cloud as well. If that's what you meant with the question. One of the other question is how to get the test results in Pcloudy. So there are various ways. For example, if you're using our own framework, your own framework, you will get the result that you have already integrated within your framework. On top of it, Pcloudy generates a lot of data, which is available in form of a dashboard. So for example, as I showed you in the test analytics section, we are generating data like videos, all the screenshots, log files, JSON formats. So that kind of report is already available to you in form of a link, which gets associated with your run itself. So depending on whatever tool that you're using, Appium, Espresso, or even if you're doing manual testing uh, by accessing a particular device, Pcloudy generates all that data by default, which is available in form of HTML report. So another question is, you mentioned about zero code automation. So in this session, I didn't kind of touch base on zero code automation, but there are other sessions happening around it. There are already some webinars available. We can just pass on the link to you, or we'll be happy to showcase a separate demo. But just to kind of give a overview of what it is, as I mentioned in the beginning, it allows users to create automation script in a codeless way. You don't need to know about any language technology behind. You just record a particular flow of your application, and then it generates the automation script for you. And that script is in a very simple English kind of language, which you can then modify by inserting certain keywords, and then start running it on devices in parallel. So that's what it is as far as the zero code automation script is concerned. It solves all the challenges that you face in tools like Appium or some of the other open source tools. It has been designed in a way that even the manual testers without knowledge of any technology or language can create the scripts. Another question is, apart from Appium, would you suggest other frameworks to achieve maximum automation? So yeah, I mean, I didn't touch upon that part, but we are seeing an increasing trend where organizations are moving towards native tools for their automation. So for example, Espresso and XUI test. These two are becoming quite popular, especially in the DevOps space, because these are much faster, because they are native to the development environment itself, provided by the operating system itself. So Espresso and XE test and XUI test are two alternatives that we are seeing in the open source world, where a lot of teams are moving to these native automation tools. And on top of Appium, there are so many frameworks available, TestNG to Robot. So depending on your comfort level, you can choose. I mean, we have certain documents which we can pass on, where those comparisons are in place, which will help you figure out what are the right frameworks. There is another question, can I do performance testing with Pcloudy? So by performance testing, if you mean monitoring the app performance on a device, yes. So when you are doing your functional test or app compatibility test on a particular device, by default, we capture data like CPU utilization, memory utilization, network bandwidth, battery consumption, etc. But if you're talking about load testing, no. We integrate with certain load testing tools like Neotis and JMeter. So while you're running your load test, parallelly you can monitor the performance of apps on the device, but it's not a load testing tool. So there are a lot of questions around zero code automation. I think we will publish a link. You can go to the demo and various help documents that we have around zero code automation. We will share that link, and that gives us a cue that we should plan a detailed session around it, and we'll plan it next very quickly. So there is another question. Why are we saying that devices should always be cloud-based only and not only the actual physical devices or combination? Okay, I didn't mean that. What I said that you can still use your internal devices, but create an internal device farm. So what I meant was that it has to be internal cloud. If you want to achieve automation at scale and you want to run automation continuously, it has to be an internal cloud. So for example, Pcloudy has an on-prem solution where it can be deployed within the organization premise, and all your devices can be connected to the system, and it becomes an internal cloud for you. And by default, then you have all the capabilities that we talked about in the presentation, like running it on parallel devices, all the test analytics, orchestration. So you don't have to create your own framework to do all these activities. So I didn't say that you can only use the external clouds. You can always create internal cloud for yourself. So hope I answered that question. So I think in the context of Appium, the question is Appium internally consumes native tools. That's right. But then since Appium sits on top of those native tools, it adds to the latency and sometimes the flackiness. So the advantage with Appium is that for both iOS and Android, you are creating scripts in one way. I mean, you don't have to learn two different tools. But if you're using native tools like Espresso and XUI test, you have to have knowledge about these two tools separately. But these are much faster. These are much faster if you compare it with Appium. And so if you're looking at speed, then definitely these tools can be an option. But if you're looking at convenience, ease of maintainability, then Appium is definitely a right choice. So there is a question for record and playback. The support for running the recorded script across OS will be available in near future. So if I understand the question correctly, one single script should be able to run on both Android and iOS. So that is totally dependent on how your application has been designed. If for both Android and iOS you have a similar UI design, the UI, the object properties are similar, then the same script can run. For whatever the scripts that we create in OpKey, the same script can run on iOS and Android. In fact, in the zero code automation studio that I was talking about, you can even have two different repositories linked to a particular script, and based on wherever you are running, it can just pick those object repositories and those properties. So it's definitely possible, but a lot of times we have seen iOS and Android applications built completely separately by two different teams. So there are a lot of mismatches. And that's the reason why you have to create two different scripts. But otherwise, technically, it's possible. So question is around what is my opinion on apps built using Flutter Dart. I mean, Flutter is one of the most popular platform that is coming up in the market. So I think a lot of organizations are moving towards creating apps on Flutter. And the good part is that platform like Pcloudy already supports applications designed using Flutter. So you can use those applications for your manual testing, as well as if you're automating using Appium Flutter driver. Again, those scripts are supported on Pcloudy. So as a platform, we make sure that we are supporting most of the app development frameworks. We are not bothered about typically the framework used behind the scene. That is a challenge to automation tools like Appium, where they have to recognize the objects. So like in case of Flutter, they had to create Appium Flutter driver separately. So for those newer frameworks, Appium comes with the support. It might take some time, but as long as Appium supports these scripts, you can run those scripts on our platform. And in our automation studio, again, as soon as a new framework comes in the market, which is popular, we start supporting that. So I'll take one more question, and then we will close the session. If there are any more questions, I'll be able to answer that as we through the email in a one-on-one way. So another question is, progressive web app can be automated? Absolutely, yes. So be it progressive web app, mobile web app, native, hybrid, you can automate any kind of application. There is absolutely no challenges. Another question is, any other testing tool you think which can be used for both iOS and Android testing other than Appium? I mean, there are quite a number of commercial tools available in the market which you can use. I mean, I'm not going to recommend any tool here. We focus mostly on the open source side, along with the automation studio that we are providing. But there are tools available in the market in the commercial space. But in the open source space, I think Appium is the choice, or you have to go native. So that's the recommendation from my side. Appium definitely is one of the best right now, and because of the community which supports Appium, I think it has grown significantly, and even a lot of bigger enterprises have started kind of migrating from their commercial tools to Appium. So that's going to be the future of mobile app automation. Except that, as I said, we are seeing some trend where especially the tech organizations are moving to native tools like Espresso and XCUI Test. So thank you so much. Please feel free to send your questions. If I have not answered any questions, I'm sorry. I'll be able to definitely answer that one-on-one. You can reach to me. My email ID is avinash.tiwari@pcloudy.com. You can send your questions, and we have committed certain documents to be shared. We'll be sharing that with all of you. Thanks for joining in such large numbers and making the session really worthwhile. I hope you're able to take back something from this session. Your feedback and suggestions are welcome. Thank you so much. Thanks for your patience.